Okay, so hello everyone, this is Akshay here, and let us cover the today's LeetCode POTD question. Today's question is of a medium category, but I would personally rate this as an easy one. So the question name is to find the difference between ones and zeros in rows and column. So let us read the question. What it says that for each and every index we need to return this particular value. That is ones row plus ones column minus zeros rows and zeros column. So ones rows is nothing but the number of ones in a row. Similarly, for ones column is the number of ones in a column, and zeros rows same as it is. To find the zeros in particular row and to find the zeros in particular column. Great. So how we can do this question? How we can approach the question? Or let us try run for one input and then we can proceed ahead. Okay. So let us talk about this index. Yep. Let's talk about this cell. So what is the number of rows in the column? Number of sorry, what is the number of ones in this given row? So ones row, or let's say I'm writing it as one row, would be nothing but 2. Similarly, what is the number of ones in this particular column? It is 1. Now zeros rows would be, it would be 0, and then 0 column would be again 2 zeros, so it would be 2. We need to return 1 zeros plus 1 column, that is 2 plus 1 minus these two values, right? And zeros rows is not 0, it is 1, right? There is 1 0 present here. Okay, so 2 plus 1 minus 2, which will give you 0, and that is why 0 is the answer, and that's what is explained in the explanation as well. So what are the methods to solve this question? First and foremost, if we do whatever the question is saying, that would be a brute force approach. That is, we will traverse for each and every cell. How many cells are there? N cross m. Now what we are doing, we are calculating these values: zeros rows, zeros column, zeros rows, and ones column, like these four values, right? So this will particularly take what to say, let's say the row length is m and the column length is n, so it will take m o of m. It will take o of n, it will take o of m, and o of n, right? So for each and every column you'll be traversing 4 times, that is 2m plus 2n. So ignoring the constant, it would be m cross n into m plus n, right? What would be the space complexity? Since we will be using a new, let's say difference 2D matrix, it would be O of n cross n, right? This would be your method 1. But can we do something more efficient? Yes. So instead of pre-computing these 4 values every time, what we will do, we will make a row array, right? Ones row, this OR is nothing but ones row, and we will take ones column array, right? And we will store the values of rows and columns in this particular 1D array, right? So what is the number of ones present in this first row? It is 2. What is the number of ones present in the second row? Again 2. Number of ones present in the third row? It is just 1, so it is 1. Now what is the number of ones present in first column? It is 1. Second column, it is 1 again. Third column, it is 3, right? Now using these ones rows, I will get the value of 0, number of zeros present in this row. I know the this the space of the particular, or let's say the values can be stored in a particular row is m, right? And I know the number of ones is 2, so I can just minus this value, that is m minus 2, and I will get the number of zeros. This will be nothing but zeros in a row, right? Similarly for column as well, I can get this particular value and minus it with the number of cells in one column, and I will say n minus 1, and I will get my zeros column, right? So let us, after making this matrix, right, it will require m cross n time complexity to make this matrix. Then again we can just again go for m cross n, that is a nested for loop, and we can update our grid. We can update our grid with grid of I and j, and what we will write, we can write as or of I plus OC of I, correct? And what we will do next, so this is nothing but number of ones in row, number of ones in column I, and I need to subtract the number of zeros, right? So for that we have decided that we will do m minus number of ones in row I, and then we will do minus number of the total length, that is n minus number of ones in column of I. So if you reevaluate, then what we can write, it as 2 star number of ones in row I plus 2 star number of ones in column I minus n minus m. That would be your final expression. So for each cell in the matrix that is greater of I j, we need to replace with this value, and that's it. We are done with this question. Correct? So now let us look at the code. So that's the code here. So we are just storing the grid length, the row and column length in m and n. We have a 2D two array of linear. We have a two array of linear dimensions, and the length is m and n. Again, we have a two nested for loop. First for we are storing the all the so we are storing the counter number of ones for each and every row. And why are doing plus 0? Because eventually the other cells are 0, so if we add it even, that would give us the no value, right?